This lesson is on special right triangles. Learning target. I'll be able to use the properties of special right triangles to solve for missing side lengths. There are two different types of special right triangles. We're going to talk about the 45, 45, 90 triangles. 45, 45, 90 refers to the name or the measure of the angles. So you can see here that you have a 45, you have a 45, and we have a 90. Since they are special right triangles, we know we're always going to have a 90-degree angle. This is going to be our reference triangle. This is the extended ratio. Remember back to other lessons. This is the extended ratio for the side lengths of a 45, 45, 90 triangle. We have the legs that are congruent, so it's an isosceles triangle, and then we have the hypotenuse, which we know is always across from the right angle. So that's the easiest part for us to find. These are the legs, okay, and they are the same. So we're going to use this as a reference triangle when we work with our problems. So let's draw that reference triangle next to this triangle, because this is also a 45 and then a 90, and that means that this up here has got to be 45, because we know all the angles inside of a triangle add up to be 180 degrees. So I'm going to set up the reference triangle, and I'm going to orient it the same way as my problem. So I know that that's 90. So since I know that that's the 90 degrees, across from it is always going to be the hypotenuse, and on our reference angle, that's the square root of 2. And then the other pieces are 1 and 1. Since these are both 45, 45, 90 triangles, these triangles are similar. And we've already learned that we can use proportions to solve for missing measures. So let's set up a proportion to solve for the missing measures. So we need to solve for x. So we'll put x there. X's corresponding side on the reference triangle is going to be 1. Then we have 16 from the hypotenuse, and that's on the same triangle. And 16's corresponding part on the reference triangle is the square root of 2. Now we have our proportion, and we can use cross multiplication to solve it. So we end up with x times the square root of 2 is equal to 16 times 1, so just 16. So now here, this right here is multiplication, and we just need to remember back to our basic solving equations. Even though this is a square root, it doesn't matter. We are going to just use our basic tools for solving equations. And because this is multiplication, we're going to get rid of it using division. So we're going to divide by the square root of 2. Those cross out. But whatever we do to one side, we have to do to the other. So now we end up with x is equal to 16 over the square root of 2. And that's the side length. However, we don't like so I'm just going to put, this is that side length that we were looking for. But we don't like that denominator in the bottom. And we have to do something called we don't like that radical in the denominator. So we have to do something to get rid of this radical in the denominator. And what we do is something called rationalizing the denominator. And the easiest way to do that is to take our problem, 16 times the square root of 2, and multiply it by something equivalent to 1. Because we don't want to change its value. We just want to change the way that it looks. So we're going to take that denominator, square root of 2, and we're going to use that in a fraction form. Because our ultimate goal is we want to get rid of the radical in the denominator. And the only way to do that is to make the number inside a perfect square. So now we just multiply fractions. And when we multiply fractions, we just multiply straight across. So we end up with the square root of 4, because 2 is both, we have a 2 inside the radical and another 2 inside the radical. So we can multiply the 2's together to get 4. And then on top, the 16 is not inside a radical. And we have nothing else to multiply that with. So we leave it as 16. And then we have the square root of 2. The 16 and the square root of 2 cannot be combined because 16 is outside a radical and the 2 is on the inside of the radical. This is all over. That's the division right there. Okay. So now we're going to keep going. So on top we end up with the 16 over the square root of 2. And on the bottom, 4 is a perfect square. So we can take that square root and we end up with 2. At this point, we can do one more simplification step, which is reducing this fraction. So we end up with 8 times the square root of 2. I'm going to write, so I'll just 8 square root of 2 is our final answer for that side length. And if you put 16 divided by the square root of 2 in your calculator, and then you put 8 times the square root of 2 in your calculator, you should get the same decimal approximation. Because they are the same number, we've just rationalized the denominator. Let's do another problem. So again, let's draw our reference triangle. And this way I'm going to orient it in the same direction that I've had before. I know that always across from the right angle is going to be the square root of 2. And that my legs are both going to be 1. So this time, I'm going to set up the proportion. And I need to solve for x. And x is the hypotenuse on this triangle. So we're going to use the square root of 2 since that's the hypotenuse on the second triangle. That's the corresponding part. And then the value that we're given is 5 square roots of 2. And its corresponding part is 1. And then again, we have a proportion that we can solve using cross multiplication. So we end up with 1 is equal to 5, oh, I'm sorry, 1x. I should have said 1x is equal to 5 times the square root of 2 times the square root of 2. We can combine things that are inside radicals together. And so now we have 5 times the square root of 4. 4 is a perfect square. So now we have 5 times 2. So our final answer for x is 10. Let's talk about 30, 60, 90 triangles. So again, we're looking at the extended ratio of the sides. This one's a little harder to work with because we don't have side lengths that are the same. In the 45, 45, 90, we had the legs were both 1. So it really didn't matter which one we used. But in this case, it's really important for us to talk about the short leg and the long leg. The easy side for us to find is the hypotenuse. It's always across from the right angle. We learned that when we talked about the Pythagorean theorem. You're going to talk about that when we learn trig. So it's right triangle, that hypotenuse is always across from that right angle. Now if we think back to other lessons about triangles, we talked about the relationship between angles and sides. And we learned that the short side is always, or I should say the shortest side is always opposite the smallest angle. And that's something that we learned back when we talked about the properties of triangles. So since 30 is the smallest angle, we know opposite it will be the short leg. And then we have 60, and we know that's going to be opposite the long leg. So we really have to pay attention to this when we set up our reference triangle and make sure that we orient it in the same way for each problem. And we'll use the 30, 60, 90, the 2, 1, square root of 3 combination. So my reference triangle should be oriented the same way. So we have a little, it's been turned on its side. I know across from 90 degrees is always going to be the hypotenuse, so I know that's going to be 2. And here, since that's 60, up here is going to be 60. So we know across from the 60 degrees is going to be the square root of 3, because that's the long side, and then leaving this over here to be 30 degrees, and that being the short side. Now, before we set up proportions, which we could solve this problem totally using proportions, but I want to talk about the relationship between the hypotenuse and the short leg. And we notice that the hypotenuse is 2 times that short leg. So we could take the short leg and double it, or we can take the hypotenuse and cut it in half to get that. So here we have the hypotenuse, And let's just cut that in half to get y. So we're just dividing it by 2. So we get 26 square root of 3. Because when we divide it by 2, we're only dividing the number outside of the radical. We could set this up in proportion to get that, but we know this relationship, and that relationship is kind of giving us a shortcut. So we don't have to spend too much time setting up proportions. But we will have to set up a proportion to solve for x. So we know we need x. Its reference side is the square root of 3. And then we're going to start with the value that we were given, so 52 square roots of 3. And its corresponding part is 2. And then we can use the cross multiplication, because it's a proportion, to solve our problem. So we're going to end up with 2x is equal to 52. And we're just going to take a shortcut and say, well, the square root of 3 times the square root of 3 is the square root of 9, because I can multiply the 3's together. 9's a perfect square. So now I have 52 times 3, which ends up being 156, and then 2x. And then I'm just going to solve for x by dividing by 2, and x is equal to 78. So y is equal to 26 square root of 3, and x is equal to 78. Let's do another problem. So again, let's draw that reference triangle. I know always across from the 90 degrees is going to be 2, because that's the hypotenuse. The 60 degrees is up in this corner again. That's going to make this 30. So we know across from 30 is going to be 1, and across from 60 is going to be the square root of 3. That's our reference triangle. So let's solve. So we know we have 13, and its corresponding part is square root of 3. It doesn't matter which side length you solve for first. So maybe we'll solve for y. And y's corresponding part is 2. So I end up with, when I do the cross multiplication, 13 times 2 is 26, is equal to this y times the square root of 3. Now we're going to divide, because that right there is just multiplication. So divide by the square root of 3, whatever we do to one side, we're going to do to the other. So now y is equal to 26 divided by the square root of 3. But remember, we don't like that square root of 3 in the bottom. This is the side length, and that's the length of the side length. We don't like the way that it's being written. We need to get rid of that denominator in the bottom. So again, this is the side length, but we don't like it being written that way. So we need to simplify it. So what we're going to do is we're going to take 26 and the square root of 3, and we're going to rationalize that denominator by multiplying it by the square root of 3 over 3, because that's something equivalent to 1. Then we end up with 26 square root of 3 over the square root of 9, and then 26 square root of 3 over 3. And this is the value of y in its most simplified form, because 26 can't be divided by 3. So now we have 26 square root of 3 over 3. We could set up a proportion to solve for x, but we do know that relationship between the hypotenuse and the short leg is just doubled. So the hypotenuse is double the short leg. So since this hypotenuse is 26 times the square root of 3 divided by 3, we can just cut that in half. And when we cut that in half, we're just cutting the number on top. So that's going to end up being 13 square root of 3 over 3. And that's the value of x. So this triangle is oriented a little bit differently. So let's draw our reference triangle. We know across from 90 degrees is always going to be 2. The 30 degree mark is up here this time. And we know across from that's going to be 1. That leaves 60 here. So that's going to be the square root of 3. We have the short side. What's the relationship between the short side and the hypotenuse? Well, if I double the short side, I'm going to get the hypotenuse. So if I just take that short side right here and double it, that's going to be 4 square roots of 3. And that's my x. Again, I could set up a proportion, but that's a really good shortcut for us to know that value. Let's solve for y. We'll set up the proportion. So y's corresponding part is square root of 3. We're given 2 square roots of 3, and that corresponding part is 1. So we do the cross multiplication, and we end up with y is equal to 2 times the square root of 3 times the square root of 3. So hopefully we're all understanding now that we can multiply those numbers inside square roots together. So we can jump right to the square root of 9. The square root of 3 times the square root of 3 is square root of 9. And that's 2 times 3. So my y value is 6. Is a word problem. The key to this problem is that we're working with an equilateral triangle. So find the length of the sides of an equilateral triangle that has an altitude length of 11 square roots of 3 feet. So let's draw our equilateral triangle. We know all these sides are congruent. If the sides are congruent, the angles are congruent, and in an equilateral triangle, we know that they are all 60 degrees. Then we're given the altitude length. Remember that the altitude is drawn from the top down to the other side, and that's the altitude has the 90 degrees. So we've just created a triangle that we can work with. Okay? We need to find the side of the equilateral triangle, so we need to find x. So we now have a 90-degree angle. Okay? We have a 60-degree angle, and that would make this angle right here, not the whole thing, just that one, 30 degrees. So we have a 30, 60, 90 triangle. So let's set up our reference triangle underneath it. We know across from 90 degrees is going to be the 2. We know opposite the 30 is going to be the 1. And then that leaves opposite the 60, the square root of 3. And let's set up a proportion. We need to find x. X is the hypotenuse of our triangle. So we know its corresponding length is 2. We're giving that the altitude is 11 square roots of 3. So 11 square roots of 3. That's opposite the 60 degrees, so we know that that's corresponding part is the square root of 3. Now, we could do some cross multiplication, or we could recognize that the square root of 3 divided by the square root of 3 is going to cross each other out. So now I'm left with x divided by 2 is equal to 11. And I'm just going to solve for x again. Our normal solving for x, like we learned way back when, just solving an equation. I'm going to multiply both sides by 2. And I'm going to end up with x is equal to 22. And that's 22 feet. And that's the side length of the tent.